Okay, let's start class. This class is is recorded, so we will teach online, and every time I will record the class and post the recording link in the Moodle. But I still strongly recommend you, if you can join the class, please do that. But if you have any time conflict for some reason, then you can watch the recorded videos after the class. So this is 7142 statistical data mining, and also 4142. So we teach this at the same time. So here I'm just showing the syllabus for the 7142s, and the 4142s is also posted in the Moodle. So we have three recommended textbooks, and the first two, and you don't need to buy them, okay? And it's not required. So these two are available online. I've already posted the link in the Moodle, so you can just download the ebook freely. And the third one, I will just use in one chapter. So if you don't buy it, that's totally fine, and I will cover that. For the handouts, I will post it every time in advance to the Moodle, so you can download it and read it before the class. For the course description, so the first 2 weeks, I will just have an introduction to the R and review the linear regressions. That's the first 2 weeks. And then I will start it to introduce to the statistical learning. So what is statistical learning? Statistical learning is similar to machine learning, but from the statistics perspective. Okay. So we will talk about advanced statistics models for the data mining, machine learnings, and then predictive analytics. So the course includes the topics like the shrinkage method in linear models, lasso, elastic net, and then we will cover the generalized linear models and the model assessment. So these are the topics mainly in the statistics field. Then I will talk about decision trees, baggings, and random forest. These are the two popular ensemble learning methods. And then we will, so all these are the supervised learning. Then we will go to the unsupervised learning topic. So that covers the principal component analysis, cluster analysis, and association rule minings. So these are the topics that we will talk about in this course. So you can see that this course is pretty packed with lots of topics. So we really have lots of things to cover. So after the first 2 weeks, we will just go through these topics quickly. And most of these topics, we also have a lab. So I will show you some examples with the R code. Oh, regarding for the textbooks, the first one, an introduction to statistical learning with applications in R and Python. So I have the link. So if you go to the book website, you can see there are two versions. They are almost the same. The only difference is the lab. So for this book and this book, all these uh, uh, all these chapters, labs are almost the same, but this one is illustrated in the R. This one is illustrated in the Python. So for the class, I will just use R. And for the homeworks, you should use R. But we do have projects. For the projects, it's free. So you can use R, you can use Python, or if some of you use like a MATLAB or other software, that's fine. But for the homework and the illustrations, that's only for R. Okay. So for the prerequisites, I have that clearly specified in the syllabus. So make sure you have some basic knowledge about statistical inference, and you should be familiar with what is linear regression models. So these are the prerequisite. For the software, you don't have to know R before, but it will be strongly preferred if you know some of the standard software language like the R, S+, SAS, C, C++, MATLAB. So all these, if you know one of them, and I would say it's very easy for you to learn R and Python, because all these softwares programming language are very similar in some ways. So this is the weekly course outlines. So I will go over that in more details for the weekly schedules in a minute. For the computing, I've already covered that. Homework. So we will have 4 to 5 homework assignment. So you have about 1 week to complete assignment, and each of you should work independently on assignment and submit the homework through the Moodles. Okay. For the final exam, although we teach remotely, but for the final exam, that will be an in-person comprehensive final exam. And I will tell you the time and date in a minute. So for the final exam, it only have 2 types of questions. One is the multiple choice, one is the true and false. Okay, so basically for the final exam, it's in-person, comprehensive, closed book, closed notes, but I focused on the conceptual questions, just testing your basic knowledge about the topics that we covered in this course. No calculation. I would say maybe minimal calculations, very simple, and but mainly to test the conceptual knowledge. For the team project, that will be your midterm project. So I will ask 3 or 4 of you join as a group and work on a project, and you can pick the data set. It can be your research data, or if you don't have any research data available, I will give you some resources so that you can get tons of data sets online, public available. Okay, so you can choose one to work on. For the final project, that will be as a individual based. So each of you work on different data sets. So you pick your data sets. There's no collaborations, and I will ask you to present for the final project. So for the midterm project, I will remind you from week 6, and then it will be presented in week 10. Okay. For the final project, you will present in the final week. In the last week of the semester, not the final, in the last week. I will show you the weekly schedule in a minute. This is the portions of the of each category that contributes to the final grade. For the homework, that counts 40%. Team project and presentation, that's midterm. Project 20%, final exam 20%, and then final individual project 20%. These are the important dates. So any questions for the syllabus? Okay, if you don't have any questions, let me just briefly go over the weekly schedule. So that is also available uh, in the Moodle. So basically, Moodle uh, is the one that I will use frequently to update, put the data sets, announcement, code, homework assignments, all these things. So check the Moodle regularly. And if I have any announcement, I will first just post it in the Moodle. Okay. So for the first week, we will have the introduction to the R's. And then second week, I will illustrate through the using R through the some examples like the Forbes example and the Boston housing examples. And then I will talk about shrinkage methods for the linear regressions. And then I will start the introduction to the statistical learnings. And these are the homework assignment date. So I will show you the first homework in a minute. And then we have the model assessment. And then for the week 4, we started for the introduction to the generalized linear models. And then we will move to the non-parametric smoothing and splines, generalized additive models. And then after the week 6, we will move to the trees and the ensemble methods. Okay? And then we will talk about the baggings, random forest, and I will show the first case study through the data mining case studies. So that will be as like an example for your midterm project. And then week 10, you will start to have the midterm group project presentations. And after the presentations, we will talk about the artificial neural network, clusterings, and then principal component analysis and association rule minings, also called market basket analysis. And then for the last week, we will have the final project presentations. And the final exam will be on December 9th from that's a Tuesday from 7:30 a.m. to 9:30 a.m. And I will tell you the room and place about a few weeks in advance. Any questions? Okay.
Dr. Lee, just real quick, for turning in the homework, do you want us to turn in an R file? Do you want us to turn in do you want me to copy and paste the R code onto a Word doc? How do you want us to turn that in?
Yeah, that's a good question. So I prefer to just have one file. So the first part will be your answers to the homework questions. And then after that, then you just post some main R code and output. That will be fine.
Okay, perfect.
Any other questions? Okay. So let's move to today's material. So we will talk about introduction to the R. So this is the outline. So some R history. So R is an implementation of S language. So first S language was developed, and S plus is a commercial version of S language, and then R is based on the S language. And R was created by Ross and Robert, so I think that's the reason why they call it R. And the project, our project started in 1991 and first appeared in 1996 as an open source software, and you can download R here. So I think I have these. Let's see. Yeah, this one. So this is the place that you can download R. Depends on the operating systems. So if you are using Windows, just click this one. And then if you haven't installed R before, you should download the base package. Okay, so that's the installed R. Very convenient. R is a integrated suite of software facilities for data importing, exporting, storage, and data manipulating, and also for scientific computations, and of course for statistical analysis and displaying the results through the tables and graphs. R is very powerful for the graphically displaying the data and the summarized results. And R is highly customizable through thousands of freely available package because this is an open source. Everyone can contribute, and you can write your own R package and submit to the R server, and they will check that. After approved, your package can be used by millions of R users around the world. So that's why there are a lot of R packages available. And if there's a new method proposed, developed, R probably is the software that first implement this new method. So R is also a platform for developing and implementation of new algorithms. And there are many GUIs to R, and some of them are free, some of them are commercial, like the R Studio, that's free, and the Evolution, that's a commercial version. So R Studio is the one that I strongly recommend you to install. So this is R Studio is very convenient to use. So if you haven't used R, you can download R Studio. And I would say that's the best choice and the best platform to use R. And for the R mailing list, if you have any questions, I would suggest you to go to the R mailing list, and there is a SIG, a special interest group. So like once several years ago, I'm working on a spatial data analysis problem using R, and I have some technical questions for using one package that's specifically for the spatial data analysis. So I cannot find answers, and I searched online, cannot get answers. So I just joined that's a special interest group, particularly for the spatial statistics. And then I send out an email asking them these questions. And within 20 minutes, I got 3 emails. Each of them give me a workable solution, but very different. So if you have any questions, I think maybe it's a good idea to join the right group, uh, and then you can ask any questions, and there are thousands of our users in the group, and they can answer your questions. For installing the R package, so install the package in R Studio. That's very easy, and you can easily see that if you have these. Let's see, you can like there's a here is the just click this one. You can install the package, and just type the names, and you can have like here the GBM. If you want to install the GBM package, just typing the name and you can easily install that. But if you use the R directly, and of course you can install the R through by clicking the package and then install the package. Okay, and then it will show you a list of R servers around the world, and choose the one that is close to Louisiana. I would say like maybe this one, say Utah, and then it will show you all the available package here. Just highlighted the one like if I want to install this package, just highlight it, this one, and then click OK. It will automatically install it. And also you can install the package through the command lines, and you can like install dot package GBM, let's say, then return, it will automatically install the package. Okay, so this is how you install the package. And after you install it, that doesn't mean you can use it. You have to open that library. So if you want to open a library, you need to, after you install it, then you can say, let's say library GBM. I've already installed that, then return, it will open that library. Then you can use that library. Okay? So install first, then open that library. Then you can use it. Okay, how does R work and how do I work with it? I think the best way to use R is you set a dedicated folder for each project, okay? And then you set the working directory as these folders. So how can we set the working directory as these folders? What you can do is you can make an R shortcut pointing to that folder. Okay, so like after you install R, there will be uh, R shortcut on the desktop, and then you can copy that and move that into the folder that you want to set as a working project folders. And then you can double click that R shortcut. Then the R will open, and this folder will be the working directory. Okay. And also another way is you can just use set WD. That function in R is to set working directory. And then you can type in the working directory, it will set that particular working directory as the working folders. Okay, but if you have any questions about this, you can always use the help menu. How to use the help menu, just type in the question mark and then WD set. Oh, sorry, set WD. Yeah. So it will automatically open help menu for the setting the working directory. It will tell you the details, and also usually it will give you an examples. Okay, so that's how you set the working directory, and then you just run the R's in that directory. And I always save, put the data sets and also the results in that folder. So that is the dedicated folder for this project. And I usually set the name of this folder as the project's name. So I think that is probably the best way to use R and working on a particular, a separate project. Okay. And you, after you used R's, and you can close the R's, and when you uh, when you closed R's, it will ask you, do you want to save the results or not? So you have three options. No, then it will leave the R without saving your results. If you say yes, then it will save the results in the .r data, that file. So all your results are saved in that file. And that is in your working directory. Okay? And if you cancel, then it will not quitting the R's. And then if you save your results, and next time, if you double click .r data, that file, it will open R. And then you can continue to work on this project. Okay? And RStudio, and this is a open source integrated development environment. It's very useful and very convenient. So if you haven't used R before, I would say just go with the RStudio, and you can download RStudio here. So any questions so far? Okay. So here are some R basics. So the default R prompt is the greater sign. So this is a R prompt, just show you that start a new line. And 2 times 4, if you return that, it will get 8. And this. So you can see R can be used as a fancy calculators, can do the calculations. And also you can assign a value in to a certain variable through the x less than minus 2 times 4. So that will be x equals to 8. And also you can replace this one. This is the assignment operator. And this is equivalent to this. You can also use this. Either one is fine. And R is case sensitive. Uppercase, lowercase, they are different in R. Okay, like here I saved it into lowercase x. But if you type in the uppercase X, it will show you object X not found because they are R is case sensitive. Okay, and you can do more complicated calculations in R, and it has the exponentials, and sometimes if you do like 1 divided by 0, it will show you IMF, so that's non-finite numeric values. Okay, and sometimes it will show you NAM, that is not a number. Here, X is infinite and Y is negative infinite. If you X minus Y, it's NAM, it's not a number. Okay, and it has some certain constant like a pi. Pi in R, PI, so that means 3.141593. So that's a constant. And if you have any questions about a certain function, you can use the question mark and then followed by the function name. But if you have any questions about a certain topic, you don't know the function's name, you just want to know is there any functions related to a certain topic? Like here, if you want to know any function that is related to the trigonometries, you can always use help.search, then type in the topic's name, or you can just do double question mark followed by the topics that you want to search. So these two are equivalent. Okay? So know how to find out the help menu, and then for a certain topic is very important so that you can learn by yourself. And there are 4 most frequently used types of data objects in R. Start from the simplest. That's it's a vector. So vector is you can consider as a one-dimensional array. So it's a set of elements of the same mode. Mode means the same type. Like we can have a C, lowercase c in R is used to concatenate streams and numbers. Like x equals to C, parentheses, hello, my name is Francis. So that means X is a string vector with 5 elements. The first one is hello, followed by my name. Okay, so and here y is a logical vector. We have 4 elements, and these are true, true, false, true. Okay, so that's vector. And then matrix. Matrix is set of elements appearing in rows and columns where the elements are of the same type, same mode. Okay, so that's matrix. We can have a matrix for all the numbers, for all the ins, for all the other types. That's fine. But data frame is more flexible than the matrix. It's like a matrix, but each column can have its own different mode. Like for the matrix, all the columns, all the elements are the same type, but for data frame, each column means represent each variable, and each column can have its own type. So we can have the first column in a data frame as numeric, but second column can be a string. Okay, and the third column may be a logical vector, and so on. And but the constraint for the data frame is, although different columns can have different types, but all the column they should have the same length. Okay, but list is a generalization of a vector and represent a collection of data objects. So it's an extension for the data frame too. So list is the most flexible. Each column can have different mode, and also it can have different lengths. Okay, so I will show you some examples in a minute. And you may ask why we need to have different types of data objects. Of course, for vectors, matrix, these one dimension, two dimension, they can be very different, and we can use both. But for data frame list, these seems that is really related to, especially if you work on some big data sets. For these simple uh, data objects, the computational speed is much faster. Okay, so sometimes you have to consider that. Although list is the most flexible, but if you work on a big data set and save it as a list, so the computation speed will be very slow. Okay, now let's see. So this is the vectorized arithmetic. So here I can say I created a variable called weight. It's a numeric vector, and it has 6 elements. And the third one is NA. In R, the NA means missing value. Okay, so then we can have the weight followed by the bracket 1. So that means the first element of weight. If you return, it will show you 60. Okay, then the height is another 6-element numeric vector that stores the height of 6 subjects. And then we can calculate the BMIs. BMI is the weight divided by the height square, right? And then if you do that, so this is called a vectorized math. So weight is a vector, height is a vector, right? Weight divided by height square, so that will do, R will do that in an element-wise way. So the first element of the weight will divide by the square of the first element in the height, and saved as the first element in the BMI. So this is the BMI for the first subject. And the third one has NA because the weight is missing, so BMI is also missing, and so on. So that's the, and also we have lots of basic functions in the base package, like mean is to calculate the mean of a vector, SD is calculate the standard deviation, and median is calculating the median. But when you use these functions, be sure that to specify the na.rm. So that means missing value removed or not. If you, by default, this is false. So if there is a missing value here, you just type in the weight, mean weight, it will show you missing. Because there's one missing value, so we cannot calculate the mean. But if you set the na.remove is true, then it will remove the missing value and then calculate the mean for the rest of the data points. And similarly for the medians, means, and the round is a common function. It will just round the numeric vectors to a certain number of digits after the decimal point. Like here, I set the d is 1, then it will be 1.8, 1.n, and so on. And scale is another very commonly used. So that will do the scales, centering and the scales. Okay, so by default, it will do the center and the scales. So that means it will subtract the mean and then divide by the standard deviations. So scale is essentially calculating the z-score of a variable, okay, and then show you the z-scores. And then if you want to know the mean and the standard deviation, it also show you the mean is this and the standard deviation is this. And this is the z-score for all the 6 points. And also, summary is very useful. It will show you the summary statistics. The 5-number summary start with the minimum, Q1, median, Q3, and the maximum. If there's a missing value, it will also show you how many missing values are there. And these are some other useful functions on the vectors like sort. It can sort the numeric variable from the lowest to the largest or from the largest to the lowest. And also we have there are 2 other similar functions like the order. It will show the order and the rank. Okay, so, and this is the random sampling function called a sample. It can just a random sample from a vector. So if I have 1 column 4, so that means in the R, if it's 1 column 4, what is that? That's 1, 2, 3, 4. Okay, and if you want to sample 1 through 4, size, let's say, is 4. Okay, and then let's say replace equals to true. So that will be sampling with replacement. So you can see 1 has been sampled 3 times. 3 has been sampled once, but 2 and 4 are not in the samples. So this is usually called the bootstrapping samples. So bootstrapping is sample with replacement. Okay, so you can also do it without replacement. So the replace is false. You can type in false or just F. Then return. It will just randomly permute the orders. So it will be 3, 2, 1, 4. Okay. But if you have the size is larger than 4, then it will have an error message because you cannot replace it false, but sample size is larger. So that will be false. Okay. But these are, notice that if you want to exactly to replicate the results, like here, if I do that again, you can see now 4 is sampled twice, 3 is twice, but 1 and 2 not. So it's not the same. That is because each time it will use the system time as a random seed to do the samplings. So if you want to exactly reproduce the results, you can set the seed by yourself. Let's say I set the seed as 10. Okay? Then I can do this. It will be that. And next time, if I set the same seed again, and if I do that, that will be the same. But if I set a different seed, let's say 1, okay, and then I do that, it's different because I use a different seed. So that is very important, especially for the scientific research. Nowadays, people em emphasize more and more for the reproducible research. So make sure that you set the seed for these random samplings so that you can exactly reproduce the results. And there are other functions like the R norm, that's the randomly generated the numbers from a normal distribution. So that's called R norm. And I want to generate 2 numbers from the normal distribution with the mean is 0 and the standard deviation is 1. Okay, so these are the 2 realizations with the mean from the population distribution is the normal distribution with mean is 0, standard deviation is 1. And P norm is showing the probability of having that number with the mean and the standard deviation. If you don't specify the mean and the standard deviation, it will use a standard normal distribution, which is mean is 0 and 1. Okay, and here the probability is the probability. So this is a normal distribution. If you specified a number 1.96, the probability will be on the left side. So all the areas on the left side of that number. So that is 0.975. That's the probability. Okay, so Q norm is reversed. Q norm is you specified a probability, then it will tell you that point. Let's say if you specified 0.975. So you want to find out the cutoff point such that the area on the left of that cutoff point will be 0.975. Then it will show you it's 0.9599. Okay, so that's the Q norm. And if you have any other question related to that, just type in the question mark Q norm so that you can see the help menu. Okay. And the matrix, you can, so here I first created an X as a vector and then I can also create an X as a matrix. So here X equals to a matrix with 1 through 12 and followed by 3 and 4. 3 is the number of rows, 4 is the number of columns. And by row is true and false. If it's true, it will be 1, 2, 3, 4, 5, 6, 9, 5, 6, 7, 8, and so on. If it by row is false, it will be 1, 2, it will by column. 1, 2, 3, 4, 5, 6, 7, 8. So depends on this. And then the dimension, DIM, that's the dimension for a matrix, it will be 3 by 4. 3 rows, 4 columns. And also you can specify the row name of a matrix and the column name of a matrix so that it will show you a matrix with the row name and the column names. And also you can combine 2 matrices. Like there are 2 functions, R bind, that's row bind. So R bind means that if you have matrix 1 and matrix 2, you can stack together like this ways. So that's called R bind. R bind. Okay. And the C bind is side by side. So if you have this matrix and this matrix, and you can combine in this ways horizontally. So that will be the C bind. Okay. And also you can do some like the additions of a two matrix and the multiplications. Multiplication of a matrix is a little bit complicated because you can multiply a matrix by a number, then it will do it as an element wise, like 3 times x. Then all the elements of the X matrix will be multiplied by 3. Okay, and Tx is a transpose of a matrix. Diagonal of a matrix, it will diag to 4, so that means that it will be a square matrix. That means it has the same number of rows and columns, but the diagonal elements will be 0 or will be 2, and off diagonals will be 0. That will be a diagonal matrix. And this is the percentage star percentage. That is the operator for doing the matrix multiplication. Okay, so that is the x multiplied by a squared matrix. But make sure that when you do the matrix, let's say A is a matrix, B is a matrix. If you want to do the matrix multiplication, okay, so let's say that dimension for the A will be, let's say, A rows and the B columns. That's for the A. But for the B matrix will be the C rows and the D columns. So the only case that you can do the matrix multiplication is the B and the C are the same. So the number of columns for the A and the number of rows for the B, they are equivalent. So under this condition, then it's a valid matrix multiplication. So make sure you know that. And then you can use a solve function in the R to get the inverse of a matrix. So matrix algebra is just like the common algebra with scalars, but the only difference is that for the scalars, you can have the addition, subtractions, multiplication, and division, right? But for the matrix algebra, there's no divide. So you cannot have matrix A divided by matrix B. No, that's not a valid operation. So in matrix algebra, what we do is if we want to do A divided by B, we do it as A multiplied by what? The inverse of a B. So that inverse can be achieved by the solve. So solve is the function in the R to get the inverse of a matrix. Okay, and if you want to have A divided by B as a matrix, so you need to A multiplied by the inverse of a B. Okay, and the eigenvectors, which we will talk about when we reach the principal component analysis later. So because for the PCAs, we need to talk about what is eigenvector. But just here, let you know that these can be easily get from using the eigen functions in the R. It shows you the eigenvalue and the eigenvectors. Okay. Any questions so far? Okay, factor. Factor is very useful for the categorical data analysis. So if you have a data set, you have some of the variables are categorical variables. You need to make sure that these variables are saved as a factor. Sometimes a categorical variable can be just showing these numbers, like 1 stand for female, 2 stand for male. So if you don't change this variable as a factor, and you run the R's, do the modeling, most likely it will treat it as a numeric vector, which is not right. Okay, so you should change that as a factor. So then the R knows, okay, this is a categorical variable, but we use 1 to indicate female and 2 indicate male. Okay, so just like that. So it's very useful for categorical data analysis. So here, I show you a very simple example. Pain is a numeric vector, has these 5 numbers. Then I created another variable called f pain, which is a factor of pain. So now f pain is a factor now, is a categorical variable. Okay, so then we can also set the levels for the F pain to be none, mild, medium, and severe. 4 levels. You may ask why 4 levels? Because in the pain, how many unique values do we have? We have 4 unique values. From the smallest is 0, right? Then followed by 1, 2, and 3. So that's why we have 4 levels here. And then you may ask, then none is corresponds to which one? I think that's not difficult to guess, right? So none corresponds to the smallest value. So of course, none goes with 0. Mild go with 1, medium go with 2, and 3 go with severe. So that's the default way. So then if you look at the F pain, you can see the value will be the first one. The first subject is none. Second is severe, and so on. So then the F pain is a factor, is a categorical variable with these levels. Okay, and a factor can be very similar to an integer vector with a set of labels. While the factor looks like character vectors, they are not. They are actually a categorical variable. Okay. So this shows some example in the as a list object. As I said, list is the most flexible data object in the R. So here you can see X is a numerical vector, Y is a stream vector, and Z, Z is also another stream vector, but they have different lengths. You can see Z has 2 elements, Y has 4, X has 3. But I can create a list using these 3 variables. So my list is a list that contains 3 variables. Age has 3 numeric values. Sex has 4 values. And matter has 2. Okay, so you can see this is a list with different types of variables and different lengths. And we can show the values of each variables in the list, and also we can add a new component. If I want to add a new component called grade, okay, so grade will be a numeric vector, has 4 elements. That's fine. So now you can see we have 4 variables. The grade is the fourth one. It has 4 numeric values. Okay. So data frame is a list of vectors and or factors of the same length. So data frame is more flexible than matrix, but less flexible compared to the list because it has to have same length. Okay, so these are some examples like age, sex. I use these tools created as a data frame called a MyDF. So this is the data frame. So why do we need data frame if it's simply a list? That's for the efficient storage and the indexing. This is especially obvious when we work on some big data sets with large sample size. Okay, so any questions so far? So today's lecture and Thursdays, I will just go over these slides. And these are some basic functions. And the homework 1 is also helps you to practice R's with some simple problems and So that's a good opportunity for you to get familiar with using R's. So the table function, that is a useful function in R to tabulate the factors and find the frequency of an object. Okay, so here I'm working on a data set that is in a package called MASS, MASS. So you need to install that package and open that package. Then I used a function called attach. And this data set is called Quine. So this is a data set that consists of 146 children information that includes the ethnicities, age, sex, and days of absence from the schools. Okay, if I use attach a data set, then I don't need to specify the data's name. I can just specify the variable name. So that sometimes save some times. If you have a data set, you just work on this data set, you can attach to this data set. Then you don't have to type in the data set's name, just type in the variable name, it will know. But each time you can only attach to one data set. Okay, and after that, you need to detach. So don't forget to detach this data set after you use this data. So this is to table the age distributions. So you can see there are 4 levels, and these are the frequencies, number of students that falls into each age group. Okay? And also you can have the 2-dimensional tables that shows the age by sex. So it shows you the number of female and males among these 4 age groups. And the indexing in R is a way to access the elements of interest. So sometimes we are not interested in all the samples in a data set, right? We are just interested in a subset of samples in the data set. So what we can do is, so we can just using the indexings. For example, X is a numeric vector with 4 elements, and they are all generated from a normal distribution with mean equals to 2. Oh, I'm sorry, mean equals to mean equals to 0, and the standard deviation is equals to 1. And I rounded to the digit, to the second digit after the decimal point. So these are the 4 numbers. And if I want to just have the first one, that's X bracket 1. If I want to have the third to fourth, that's this way, X bracket 3 column 4. If I want to have the first one and third one, that's this one. So this is how we get the first and fourth. If I want to remove the second and fourth one, so that will be within the bracket is minus sign, then C parentheses 2, comma 4. That will just remove the second and fourth. Okay, and we can also do the indexing for a matrix. Like here, Y is a matrix, 3 rows, 4 columns, and we can have the second row, third column elements. That will be 8. That's the second row and the third column. So it's 8. But we can also show all the elements in first row. That's this one. And that's the fourth column of that matrix. This is this one. And also we can indexing a data frame or a list. Okay, like here the date for the data frame that shows the first variables. Right? And for that shows the first subject, first row of that data frame. So the first row is age 31 and sex is male. Okay, and also we can index a variable just by using the dollar sign followed by the variable name. So that will be showing the variable called sex in the my df data. Okay, and also we can index a list. Okay, so this shows the third variable for that list. It's meta. It has two elements. Okay, and also we can have the first elements in the third component of a list. So it will be the first element for the third one, which is meta. Okay, so that will be the lambda. Okay, so there are different ways we can achieve the same goals, but using different ways. So these are some examples for the indexing. And these are the direct indexings. And also we can have conditional indexings, which is more useful because the indexing, sometimes we want to condition on another variable. Okay, for example, we have these three vectors, okay, pain, sex, and age, and these are for 5 subjects. We have their pain levels, sex, and age information. So I use a which function to find out what are the subjects are males. So you can see it shows first, second, and fifth, right? So I can show the pain level for the male subjects. So the pain with bracket, sex equals to M. So that shows the pain level for the males. And this is the pain level for all the subjects as the age is greater than 32. And this is the pain level for all the subjects with the age is greater than 32 among the males. So you can see that these indexings are depends on one or more than one variables. Okay, so these are called conditional indexing. Okay, so this is the part of the homework 1, which I've already posted. So for the homework 1, let me see. Homework 1, that is due next Friday, not this Friday. So you have enough time. And save the homework 1. So after you work on the homework 1, save your file in one file with your names, okay? And in the Word files, docx, that's fine. And then so the first one is read assignment. So you don't need to turn in anything. So that's the section 2.3 in the ISLR. So that's the for the introduction to using the R's. So read that sections. So if you are not familiar with using R, and then work on the 10 exercises on slides 21 to 22 in your handouts. And these are the slides 21. Okay, and also these are the 22. So these are the 10 problems. And also we have some more exercises later. But here, for these 10 problems, I want to mention a one. That's the fifth one. So find the intercept and the slope for the following data set using the matrix formula of this. So in the linear regressions, we know that the way we calculate the beta hat is through what? In the matrix format, that will be the X transpose X. Then take the inverse and the X transpose Y. So that's the matrix formula to find out the coefficient vector. Okay, so when we do this, so we have the X, we have the Y, we only have one predictor. But when you do this you need to save the X as a what? How many columns do we need to have? We need to have, so here we have 1, 2, 3, 4, 4 variables. So we need to have 4 rows by 2 columns. The first column, remember to save it as a constant 1. Okay, then the second column, save it as the X, 3.15, the first one, and negative 0.55, and so on. Why we need to have a first column as a constant 1? Because that's for the intercept purpose. And then you can just use these formula. Okay, if you don't know how to do the transpose of a matrix and inverse, look the previous slides I've already mentioned. So for the transpose, you just use a T parenthesis of a matrix. For the inverse, you can use the solve function. Okay, so to find out the intercept and the slope. Okay, so that's probably the most difficult question for the homework 1. And the rest are quite simple. So if you have time just to work on that, but that is due next Friday, not this coming Friday. Okay. Any questions for the homework? Okay. Then we will talk about the graphics in R. So R has a variety of graphics functions, and they are generally classed into 2 groups. One is the high-level plotting functions, which means it starts a new plot. One group is the low-level plotting functions that add elements to an existing plot. So each function has its own set of arguments, and the most common ones, like the x-lim, y-lim, these are the limit, range for the x-axis, which is horizontal axis, and the y-lim, that's the range for the vertical axis, y-axis. Okay, and the PCH, that's the pointing character, COL, that's the color, and the LTY, that's the line type. For the line type, like the usually the line type 1 means a solid line, and line type 2 is a dash line, and so on. Okay, so X label, X lab, Y lab, these are the label for the X and Y axis. Main is the title, the main title for a graph that is on the top of a graph. The sub is the subtitle that's at the bottom. Okay, so these are the general most common options for most of the functions in R. And for the general graphing parameters, you can use the PAR function to set that, like the font size, like the margins of a plot, and also for the multiple plots per page using the MF row and the MF column. M multiple figure by row, multiple figure by column. Okay. So these are the examples for the high level graphic. So like the dot chart, it start with a new plot using with a dot chart. Hist, that's histograms, bar plot, and so on. These are the example, but R has tons of high level graphics. So I'm just showing some of the most commonly used high level graphic functions in R. And these are the low level graphic functions in R, like points. It's not creating a new plot, but adding the points to the existing plots. Symbols, similarly, but the difference between points and symbols is that the diameters or so the diameters of the point of a circle is related to a third variable. Okay, so here we have X variable, Y variable, right? You can also have the third variable, let's say Z. So the size of the circles is related to the z. So that's the difference between points and symbols. An outline is to add a line, arrows to add some arrows, box is just adding a frame, framing a box of an existing plot. Lines, the difference between outline and the lines is that lines can be a curve, but outline is just a straight line. Okay, and the segments is just showing a segment of lines, adding a segment of lines on the plot, on the existing plot. Text is adding some text. Polygons is adding some polygons, and you can also fill with different colors. So here I'm showing some examples. So this is I used a data set called the Cars 93 in the math library. And question mark Cars 93, just showing the help menu for this data set. If you want to know the details about this data set, you can do that. And then after that, I used a PDF function. That is to create a PDF file. So in R, there were different functions. You can create different types of graphs, like the PDF is one, PostScript is another one, and JPEG, TIFF. So there are many functions that can create different types of graphic output. So here I'm setting this PDF and setting the name of the files and the directories. And then I set the size of the graph created. And I specify in the PAR function, that's MF row 2 by 2. So that means the output will be 2 rows, 2 columns. Like here, 2 rows, 2 columns. Okay, and the Y is MF multiple figure row, because that's by row. So this will be the first one, this will be the second one, this will be the third one, and the fourth one. If it's MF, not row, but column, COL, then this will be the first one, this will be the second one, and this will be the third one, and this will be the fourth one. So by row or by column. Okay, so that's the subtle difference. And then I do the histograms on this data set. This data set is about the cars. It shows the MPGs on the highways, on the locals, and also the weight of the cars and so on. These car informations. So this one shows the histogram for the MPG, mile per gallon on the highways, and then followed by the box plot. And then I show the density of the MPG on the highways, and then the QQ norm. So these are the four: histograms, box plot, density plot, and the QQ plot. Okay, so the histogram, you can see, based on histogram, we can see there was some skew to the right. We have some outliers here. The main body is here. So the most of the cars falls into 25 to 30 MPGs, right? And the box plot also shows that. So the box plot is 5 number summaries. Okay, so like this, the bottom one is the minimum, right? So the bottom one is the minimum, and the bottom of the box is the Q1, right? And the top of the box is the Q3, and the horizontal line inside the box, that's the median. Okay, and the top of the box supposedly to be the maximum. But why we can see there are some data points outside this? That only happens if we have some outlier. Okay, so what is the definition for the outlier? The outlier is defined in, so if the outlier, or if the sample is greater than the Q3 plus 1.5 times the interquartile range. Okay, what is the interquartile range? Interquartile range is Q3 minus Q1. Interquartile range is defined in the statistic called Q3 minus Q1. So in other words, in the box plot, that's the height of the box. So the height of the box, that's Q3 minus Q1. So if the point is above 1.5 times the height of the box, then they are considered as outlier. So this bar is, instead of the maximum, that will be what? That will be the Q3 plus 1.5 interquartile. Is that clear? So that only happens if we have some outliers. So then this top line is not the maximum, but the Q3 plus 1.5 interquartile range. Those outliers will be shown. And for the below, if we have observations is less than Q1 minus 1.5 interquartile range. So in other words, if we have some data points which is below the box by 1.5 of the height of that box, then it will consider that as outlier 2. So this is a density plot. It's a smoothed version of histograms. However, the density plot has a constraint. So that's why it's called a density. Because in the statistics, the probability density function, PDF, has a constraint that is the total area under the density function will be what? Will be equals to what? 1. So that's why you can see the scales for this and this are different. For this one, it's by frequency. For this one, that's numbers so that it makes the total area under the density curve to be 1. But the shape will be similar. It also shows the skew to the right. Right? A normal QQ plot, that is the common plot that we used to check the normalities. So if the data points are normally distributed, all the points will fall very closely to the line. Okay. However, we see some deviations from that line on the right end. So that means it's skewed to the right. Okay. So this is commonly used to check the normality or not. So the data points are normally distributed or not. Okay. So I think let's stop here. If you have any questions, let me know, and you can start to work on the homework 1. And after class, if you still have any questions, send me the emails. I check emails several times a day. Any questions? Okay, if you don't have any questions, let's stop here.